In this lecture, we're going to learn about the size and capacity of an std string. And before we say anything about this topic, please remember that your std string is really implemented on the inside using row character arrays like we have been doing all along. So the size and capacity information is really going to be working on this structure of character arrays that we have in memory. Here are a few examples of a few strings you can declare in your code. We say str1, and we're going to initialize this with hello world. We can also set up str2 and not give it any kind of initialization. It's going to be an empty string. And if we do str3 like this, it's going to be initialized to an empty string as well. So we have a few facilities to check if a string is empty in C++, and we use a few functions or behaviors defined on the std string type here. One of those behaviors is empty, and this is basically asking the string if it is empty. If it is empty, this is going to return true. If it is not empty, this is going to return false. So for now, I want you to guess what we're going to get printed here. str1 is not empty. This is very obvious. But what about str2 and str3? I'm not going to tell you this. We're going to find this out together in Visual Studio Code, but try to think about this. We also have another behavior called size, which we can use to query and ask a string how many characters it has inside. We have touched on this a little bit, but here we're going to really learn the meaning of this. So str1 size is going to say however many characters we have in here. And again, I want you to guess what we're going to get when we do str2 size and str3 size like this. We also have another behavior or function that is called length, and it is going to give us the same information as size. So you can use these two things interchangeably. We also have another behavior that is going to give us the max size of a string we can have on our system, and we can call it and get this information. And you should make sure that you don't go over this number in your string. So you should have no more than this number of characters in your string. If you try to do that, you're going to probably get a crash. It is a bad thing. And an interesting thing to see is that this number is surprisingly similar to the number we can't really go over in a character array. And again, this is a hint that std string is really using a character array underground. We just have a nice interface on top of it to be able to do things we do with std string here. But on the inside and in memory, it is just a character array. And this is pretty cool. We also have another behavior called capacity, which is going to give us the current maximum of characters we can have in a string. And this is a dynamic thing. It is going to update itself dynamically if you try to put in more characters than your current capacity can really handle. And we're going to see this in a minute when we get to Visual Studio Code. But this is something you have to keep in mind. It is the current maximum number of characters you can have in your current string as you have it the moment you are using it here. For example, here, if we say the sky is blue and all these things here, our capacity is going to be some number, and we can print it out and see it. But if we try to add more characters, our capacity may grow, because the capacity really says the size of the current array representing your std string on the inside. And if you try to append something on the string and the current array can't really handle that, the std string is built in a way that it is going to deallocate the current smaller array. It is going to allocate a new bigger or larger array, and it's going to store in the data. So the current capacity is really the maximum number that you can fit in the current array without really going overbound. I hope this makes sense. We have a method that we can call to actually get std string to expand its capacity, and that function is called reserve. So if, for example, the current capacity is 15 and you want it to be really 100, you can call reserve on your string, and the capacity is going to be updated to 100. And we're going to play with this in a minute in Visual Studio Code. We can also call a function called shrink to fit, which is going to reduce your capacity to however many characters you have in your string. So if your capacity is really huge, for example, you have a capacity of 100 and you only have 20 characters in your string, the capacity is going to shrink to fit the 20 characters that we have inside. This is what we mean here. And we're going to play with this in a minute when we hit Visual Studio Code. And this is really all I have to share with you as an introduction to the behaviors that have to do with size and capacity. We are going to head over to Visual Studio Code and actually play with us. Okay, here we are in our working folder. The current project is size and capacity of stdstring 15.9 here. So we're going to grab our template files and put them in place. And we're going to open this in Visual Studio Code pretty quick. And we're going to include our string library. So let's do that. And we are all good to go. The first thing we want to do is declare a few strings and try and query if they are empty or not. Again, I told you to try and guess what we're going to get here. We're going to get the answer from the compiler. I don't want to tell you, I just want to try and guess. That's going to be much more fun. So we're going to bring up our terminal because we want to run our program here, and we're going to build with GCC, which is going to build successfully. So the build is good. We're going to clear and we're going to run Rooster. And let's see what we have here. Okay, the first string is not empty because empty returns false, but the second and third one are empty. So if you don't really initialize this guy, it's going to be initialized to an empty string anyway. So str2 and str3 are going to be empty. And the braced initializer here is going to make your string empty as you see here. So this is the point I wanted to make. We can also try and get size information from these guys. So I am going to put in a piece of code to do that. And this is nothing really complicated. We are calling the size behavior on our string, which is str1, str2, str3. And we're going to get the information printed out here. It's going to say whatever string contains however many characters. And again, how many characters do you think we'll have for str1? Well, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's not going to count the null character. This should give us an 11. We're going to put that here. String 2 and string 3 are empty, so we should get a 0 here. That's my guess. And we're going to try and build and see if we get the same result. So let's do that. We're going to build good. Build is finished successfully. And let's clear and run Rooster. And we're going to see that string 1 contains 11 characters, which is what we expected here. And 2 and 3 contain 0 characters because they are empty. This is interesting. We can also use the length behavior, which is going to basically give us the same information. We can copy this and modify it a little bit. Let's go down and say length. And what we're going to do is to use the length behavior here instead of the size behavior. So we're going to say length here, and we're going to build again and see this run and see the output. The build is good as usual. We're going to clear and run Rooster. You're going to see that we get the same things, regardless of whether we use length or size. So these are two things that do similar things in C++. We are going to comment out everything we've done so far because I want you to see something else. So we're going to comment all this block out. We are going to go down and query the maximum size of an std string. And this is a behavior that is basically going to tell you the maximum number of characters you can have in a string, in an std string, I should be specific, on your system. And this is going to tell me this number here on my system. It may be different on your system. You will have to run and find that out. For now, let's try and run and see this number printed out. The build is going to be good, so we clear and run Rooster. This number happens to be, oh, it's really huge here. We can have this number of characters in this string here. Okay, this is a huge number. So if you try to have more characters than this on your system, you're probably going to get a crash because the system is not going to support it. The next thing we're going to look at is the capacity of an std string. And we get that by using the capacity behavior here. We have two strings defined here. One is going to contain hello world, the other is going to contain str2, which is going to be empty. And we're going to try and get the capacity printed out. One thing I want you to know is that the capacity is the maximum number of characters you can put in a string as it is now without getting it to expand itself in memory. Let's try and run this, and I am going to try and explain this here. So we have str1, we're going to print the capacity. We're going to try and change str1 to something really huge, bigger than what we had before, and we're going to see what happens at its capacity when we print it here. So we're going to build. Let's bring this up and give ourselves some breathing room. We're going to build with GCC. And the build is going to be good. We can clear and run rooster. And you see that str1 capacity is 15. str2 capacity is 15. So what does this mean? str2 is not even initialized, but it has a capacity. So that's the size of the array that is allocated by default inside stdstring. By default, we can really put in 15 characters. And if we try to go over that, the stdstring type is smart enough to deallocate whatever array it had now and allocate a new larger array and copy the data over. So that's what happens when we assign this larger string to str1. You see that the capacity is going to update to 75 because that's going to try and fit all these characters that we have in here. Okay, now that we have this, let's try and see the comparison between size and capacity here. Let's go down and say str1 size. We're going to print that out. So we can build this and see what we get. The build is going to be good. So we're going to clear and run rooster. You're going to see that the size and capacity are now equal. This is at full capacity now. But the capacity really is the maximum number of characters you can put in the string as it is now without it expanding itself. The size and capacity might be different. For example, on str2 here as it is, its capacity is 15 by default as we have seen here, but its size is 0 because it is empty. It has 0 characters in, so the size is going to return 0. I really want you to make it very clear what is the difference between size and capacity, because if you get that confused, you're going to be having a lot of problems in your programs that use stdstring here. Let's comment this out. I hope this is clear now. We're going to go down and comment this. The other thing we want to see is that we can update the capacity of the string. And here is a simple example to play with us. We have a string. It is called str1. Inside we have hello world. We're going to print the capacity and the size that we have in here. And we're going to call a behavior called reserve. And what this is going to do is going to set up a capacity of 100 for this string here. So we're going to see the default capacity, which is mostly going to be 15. That's what I think I've seen on most systems. And if we reserve, the capacity is going to update to 100. And that's going to be the maximum number of characters we can fit in this string without it dynamically updating its capacity as it grows. This is the meaning here. So we're going to try and build this with GCC. Let's do that. And we're going to build good. If we clear and run rooster, we're going to see that the default capacity is 15. We have a size of 11. After we reserve, we're going to have, why do we have hello world here? We're going to print the string here. Okay, no problem. After we reserve, we're going to have a capacity of 100 and a size of 11. The size is not going to change because we have an 11 characters here, hello world. If we count, we're going to get 11 characters, but the capacity has changed. Now we have the ability to store 100 characters in here. And what this is basically going to do when we call reserve, this array that we had that has a size of 15 is going to be wiped out from memory. We are going to set up a new array which is going to have this new size, and we are going to copy the data over. This is what stdstring is basically doing in the background. But we have a nice interface we can use to just call reserve, and we're going to have a bigger array we can store in our data. And this is going to be very clean when you look at your code here. You don't have to go in and do all kinds of crazy things with character arrays. stdstring is going to abstract all that away from you. And this is really cool. The next thing we're going to see is that it is also possible to make the capacity shrink. Let's comment this out and show you that in a minute. We are going to go down here and put in the code we want to play with. It is basically the same thing we've done before. Now we have a string. We're going to update its capacity to 100, and it's going to have a capacity of 100 after we hit down here. So we're going to print that out. But if we call shrink to fit, the capacity is going to shrink and fit the number of characters that we have in the array. Here we know that we have 11 characters, and here we're going to get a capacity of 100 because we reserved a capacity of 100 here, and the size is going to be 11. The size is not going to change. If we call shrink to fit is going to notice that we have more capacity than we are using here, and it is going to shrink the capacity to just 11 characters, and that's what we're going to have here. This is what is happening. And the size is going to be exactly the same thing as the capacity. Let's see if I am right. We're going to try and build this with GCC. The build is going to go through. We're going to clear. And if we run Rooster, notice what we have here. Okay, it's not going to shrink exactly to the number of characters we have in here. I was wrong about this. But what it's going to do, it's going to reduce the capacity and put that to something reasonable. We have 11 characters in here, and the capacity is going to be shrunk to 15. But the important thing is that this guy is going to shrink the capacity to something relatively smaller than what we had before. It's going to be in relation to the number of characters that you have in your string. I don't know exactly how stdstring is doing this, but know that it is going to shrink whatever capacity you had if it happens to be too large compared to the number of characters that you have in your string here. And this is really all I set out to do in this lecture, to show you how you can use the size and capacity methods. I hope you have a clear idea about the differences between size and capacity. We are going to stop here in this lecture. In the next one, we're going to look at the facilities that allow us to modify our std string. Go ahead and finish up here and meet me there.